right, so I already attempted this. It didn't go quite so well because I had a bad setup, but now restarting the video. Anyways, so I have water, make sure it's distilled because that means it's pure. And then drain opener, which is sulfuric acid. It's 93% sulfuric acid. The other 7% is water. We're not too worried about that. It doesn't matter. And that's some salt, almost half a cup of salt. And then in this little container, glass container with the plastic over it, it is the sulfuric acid. It is about 13.5 tablespoons. So my original ratio was 4 tablespoons of salt to 6 tablespoons of acid. So I kind of multiplied that a little. So now we got 8 tablespoons of salt and about 13 tablespoons of acid. I got a little bit extra acid just so I make sure it gets used up. And then right here I have a glass container. It's full of warm water. Well, it was hot. Now it's warm because it's like 15 degrees out here. And then we have a container inside of it. It is empty. So what I'm going to do is I'm going to pour the acid into the container. And then I'm going to pour the salt into the acid. And then I'm going to immediately put this plastic container on top of that. Now, it just so happens, what a lovely coincidence, that this little container fits perfectly on this glass. Nice fit. So I like that. That saved me a lot of trouble. So we're going to go ahead and do that. So I'm going to put the acid in. There we go. Oh, S-word, I'm not wearing my mask. Ugh. Hold up, give me a second. I gotta go put my mask on. Because this makes a lot of toxic fumes that I do not want to breathe in. I already got a little bit in my lungs and it wasn't fun. Where'd I put the thing? Oh yeah, it's inside. All right, we are back with our flowery, stupid bandana mask. I wish I had a regular mask, but that ain't happening today. So I guess I'll just live with this. So we got the acid in there, bathed in warm water. Warm water is to keep the reaction, like give it a little bit of energy so it keeps going, because it's 15 degrees out here, it could slow down a lot. So I'm gonna have to make sure, and it's because this stuff reacts fairly fast. If you've ever done baking soda and vinegar, it kind of goes like that. So I'm gonna put this in here, and then I'm going to immediately put this on top. I wish I had a more sealed container, but this had a metal lid to go with it, and that would just corrode. All right, I got a warm rag here. I'm gonna put it over top to catch fumes. Yo! So, as you can see here, that vapor is not the water in the cold air. It is hydrogen chloride. I wanted it to stay in the container, but it's making that at a fast pace. So that gas is very toxic. You do not want to breathe that in. So as you can see in there, it's bubbling a little bit. The bubbles in there, the white part of the bubble is the sodium, sulfur, oxygen, blah, blah, blah compound byproduct. And the gas inside the bubbles is hydrogen chloride gas. So actually now that's going at a steady pace. So when I first poured it in, it went foof. So now that it's slowed down a bit, Man, I did not need that warm water. Now that it's slowed down a bit, where'd I put that little container? There it is. Now that it has slowed down, I have this little container filled with distilled water. It's nice and cold. So what I'm gonna do, yo man, I need a better mask. Okay, let's stand back a bit. That ain't fun. Oh, okay. Now this would have gone a lot better. I just do not have the proper equipment for this at all. Okay, anyways, so I'm gonna take that lid off. I'm gonna put this little jar of cold water inside, and then the gas should spill into the jar and condense in the water and dissolve. And then we'll have hydrochloric acid. Yeah, these latex gloves aren't the best. The gas does corrode the gloves a little bit, but it's better than corroding my hand straight up. So we're gonna take this off. Also, these containers, these containers I'm using, if you look closely, there's a little number 2 inside of that recycle triangle. That means it is high density plastic and it will not dissolve in acid. Make sure you use that kind. Most say number 5. You don't want that. It will turn into goo. So I'm putting that in there. Also, these tongs will corrode, but not as fast as plastic. But I don't think I got them touching the acid, so we're gonna put that on. So now, those bubbles should build up gas, and it will, in the container, it will build up, and it will go into that little jar I just put inside, and it will dissolve in the water. And then we will have hydrochloric acid when we're done, and I will test it with litmus paper and see if it turns red. If it does, then we have an acidic solution. Yeah. Make sure you do this outside if you do it. Holy S word. That stuff is not fun to breathe in. All right. I will go get some wet rags, and then I will be back in like an hour or 2 to check and see if the reaction has simmered down. Make sure you put a folded wet and damp towel over it. It'll catch the gas to keep it from getting out. It'll help with all those toxic vapor. All right, I am back, and I took the rags off, and it is done simmering. It looks like the byproduct, the white sludgy stuff, it looks like it froze into a big clump. There might still be some leftover salt in that clump too. But other than that, it is unused acid and frozen white clumpy stuff that I will find out what it is later. So, looking in here, our small container is full of the water. Hopefully we got a lot of the gas dissolved into that water. Looks like there's still some bubbles left over that got stuck under the glass. It's still bubbling a tiny bit, like a tiny bit. Yeah, other than that. So what I'm gonna do is I'm gonna take this little jar out. We're gonna go test it, and then everything else we're gonna wash out with baking soda and water to neutralize the acid. Here is the finished products. This is the sludgy stuff that was left over, and this is the hydrogen chloride dissolved in water. Now, hopefully it is that. Hopefully I didn't mess up this whole experiment. So I'm gonna test it with this little piece of litmus paper on the end of a toothpick. All right. If it is acidic, it will turn red. piece of paper will turn red. Oh yeah, look at that. That is bright red. So that leaves two things. Either this is the sulfuric acid, the drain opener accidentally spilled into the container, or we have hydrochloric acid like we wanted. Now I'll find some chemicals to test whether it's hydrochloric acid. So let's put that away for now. And the sludge will go into storage next to my other garbage chemicals for testing with later for who knows what exotic reasons. So give me a minute while I go figure out how to test this to see whether it's sulfuric or hydrochloric acid. All right, for testing, I looked it up, and sulfuric acid will strip the water from sugar, leaving behind carbon, so technically burn it and make it turn brown or black. And same thing with this rag I was using. It's cotton, so that worked. So we're going to take a little dropper and we're going to drip a little bit onto each and test to see if it chars it. If it doesn't, we have hydrochloric acid. And then put the dropper in, get a little bit, put it on the sugar. Oh yeah, we have succeeded. Put a little bit on the shirt. Yep. We have hydrochloric acid. Very strong too. Like pH of 1. Yeah, you don't want to put your fingers on that. Look at that. Nice and clear. It just dissolved. So yes, we have hydrochloric acid. That is how you make hydrochloric acid. And the gases that you also wanted, one guy on YouTube wanted me to make, that's kind of why I started this video, was a certain guy. He wanted me to make hydrogen chloride gas. And well, it's kind of hard to capture a gas, but once you dissolve it in water, it makes it a lot easier to keep it contained. So that's how you make it. Just a quick note, when you're finished, wash off your gear with baking soda and water.